Hi guys, hi year 12. Welcome back to maths and my first video of chapter 10. Hopefully you have looked at the videos by Pete Hart for 10A and 10B, and you've done the work that has been set for that, and now I'm going to go through 10C. Have a read yourself of this here. I will summarise it. So that's page 162, forces and acceleration. What I'm going to do in this video is I'm going to go through some questions. I'm going to go through this example 7. I'm going to go through a few of the questions here and then set you some to do for your learning check, to check you understand. So let's go. Right. What this chapter is about is a law called Newton's second law of motion, which says that force equals mass times acceleration. It's called the equation of motion. So write this down in your books. Force equals mass times acceleration. Now, when we look at an object on Earth, then the force acting on the object is weight. So I want you to write this down as well, please, is weight. This is the force. So I'm comparing this equation to F equals ma. This is the mass of the object. Remember, mass and weight are different. And G is the acceleration due to gravity, which is always acting down on the object. And for the purpose of this chapter, unless it says otherwise, treat G to be 9.8 meters per second squared. So G is the acceleration due to gravity acting down on an object. M is the mass of the object, and W is the weight of the object. So when we think about objects going into space, the mass stays the same, but the weight changes because gravity changes. When you go, for example, to the moon, gravity becomes much less and you weigh less, but your mass stays the same. So, quick diet for me there, go to the moon. Right, so let's look at an example. I'm going to go straight to question 5. Exercise 10C, and it says the forces act on the body cause it to accelerate as shown. So the acceleration is upwards. I've got this pulling force P bringing this object of mass 2 kilograms is going to make it go upwards. So I always start off with my rule F equals ma. Now, I do what's called resolving the forces. Now, I'm going to look at my motion as going upwards. So my total force going upwards, I've got P going upwards, but the weight of the object, remember, weight equals mass times gravity. So the mass of the object is 2. So the weight coming downwards is 2g. So the total force going upwards, I've got P going upwards, 2g going downwards. So if I do what's called resolving vertically, I've got P going upwards and 2g going downwards. Now that is equal to the mass of my object, which is 2, times the acceleration of my object, 3. And I resolve in the direction that the object is moving, i.e. upwards. So I'll just recap that again. When I've taught this in the past, it's this bit here that students struggle with. So my force going upwards is P, my force going downwards is 2g, so my total force upwards is P minus 2g. Now from this I can now find P. So P, I can put G to be 9.8 into here, equals 6. So if I work this out, I get 6 plus 2 lots of 9.8. And if I work that out, I will get 25.6. And my force would be in what we call newtons. Okay, so that was question 5, 5A. And I'm now going to look at 5B, this question here. Okay, so I've got a mass of 4 kilograms. So the weight of the object, remember this is weight. Weight is mass times gravity, 4g. I've got weight acting downwards. Weight always acts downwards on the object. I've got a pulling force of P going up on the object. And I've got another force of 10 acting down on the object. And this makes my object accelerate downwards. So now I'm going to do F equals ma. I'm going to resolve downwards on this object. So let's look at the forces acting on this object. I've got 4g going down, that's positive. I've got 10 going down. Remember, I'm resolving the way the acceleration is going. So I've got plus 10 and I've got minus p. And that equals to the mass of my object, which is 4, times the acceleration of my object, which is 2. So if I put g to be 9.8 into here, I will get P in the end of this to be 41.2 newtons. Remember, G is 9.8. Okay, my next question I'm going to look at. I'm going to go as slowly as I can through this. This is the start of the tricky work in chapter 10. Okay, now I'm going to look at question 6a. Now, in this case, I'm given the acceleration. I'm not given the mass. Okay, so I want to find the mass of this object. So the object is accelerating downwards. That means that this must be more than 10, otherwise it wouldn't go downwards. If these were equal, then it would just be in equilibrium and wouldn't be moving. So, remember, we always start off with this, F equals ma. We say that we're going to resolve going downwards. So what have I got on this object? I've got mg going down and I've got 10 going up. So that's my total force on the object. Equals the mass of the object times 5. Okay, so I want to find out what m is. So let's put g is 9.8 in. So I've got 9.8 m equals 5m. Collect all my m's onto the one side and take my 10 to the other side. So 4.8m equals 10. So m will equal 10 divided by 4.8, which will give me 2.1. And it's a mass, so that will be in kilograms. Okay, I'm going to leave 6b for you to have a go at doing on your own as part of the work that I set you. Okay, next question. Question 7a. In this question, you're asked to work out the acceleration of the object. So, we're going to use F equals ma again. Which way am I going to resolve? I'm going downwards on the object. So, I've got a force of 2g going downwards, that's positive, and 8 going upwards, so that's negative. The mass of my object is 2, and the acceleration I would like to find out. So if I put g to be 9.8 into this formula, into this equation, sorry, and if I work out this side and I divide by 2, I will get a to be 5.8 meters per second squared. Right, well, I think that's enough for today. I'm going to leave the harder questions for the next video. So what I would like you to do, please, in fact, I'm only going to ask you to do on exercise 10c, please can you do, this is on page 165, I'd like you to do question 6b and question 7b. I'm only going to get you to do those 2 questions because it's fundamental that you completely understand this before I go on to the harder work. So I don't want just the answers, I want a diagram drawn, I want it beautifully set out. Please don't copy the solutions from the book. Please make sure you're doing your own work and checking that it's correct and marking it. There's only 2 questions, so do it beautifully, show me your method, and I look forward to getting that work. Have a lovely day.